Okay, so every ignition system has two sides, the primary and the secondary. Without the primary, you don't get a secondary. That means that you can have a problem with either side of this. If you don't have the primary, you don't get the secondary. So any of the problems with these primary components will lead to no spark. So our primary side includes the battery, the ignition switch, the primary windings of the coil, the pickup coil or crank sensor, and the ignition module or igniter. Right? Those are the primary. That's all the stuff fed by the battery. Therefore, creating the seed for our secondary spark to come out. The secondary ignition side is the secondary windings of the coil, the distributor cap and rotor if it has it, the spark plug wires if it has them, and the spark plugs themselves. Okay, so you can see that we either have something that's primary or secondary except for the coil, which is both. So we have two types of designs. We have a married coil and a divorced coil, right? The windings are what are making that be, either married or divorced windings. An ignition coil containing two windings, a primary winding and a secondary, and these windings are connected at one end or completely separate. Married are called a tapped transformer design. The primary winding is electrically connected to the secondary at one side. This commonly is used in older distributor type ignition system coils, as well as many coil on plug designs, right? Anything that has a single secondary port. The inductive kick, called flyback voltage, is created when the primary field collapses, and it's used by the PCM to monitor the secondary ignition performance. A divorced coil is called a true transformer design, and it's used by most waste spark ignition coils to keep both the primary and secondary windings separated. So you'll see in this one, they're both tied together. That makes it a married design. And you'll see the symbols of a divorced when we look at waste spark. So in order for this switch, this control of the coil to occur, we need some form of switching or triggering. For any ignition system to function, the primary current must be turned on to charge the coil and off to allow the coil to discharge, creating high voltage spark. Remember, this can happen on the positive side or the negative side. This turning on and off of the primary circuit is called switching. The unit that does the switching is an electronic switch, such as a power transistor. This power transistor can be loaded into any of the following locations. It can be in an ignition control module, it could be in the PCM itself, or it can be built into the coil itself. The device that signals the switching of the coil on and off is called the trigger. This is known as a pickup coil or a crankshaft positioning sensor, and there are three types of devices used for triggering. We can have a magnetic sensor, we can have a Hall effect switch, and we can have an optical sensor. These are the three ways that we get our signal across to fire the coil. To get the spark out of an ignition coil, the primary coil must be turned on and off. This primary current is controlled by the transistor, the electronic switch, inside the ignition module or igniter that is in turn controlling one of the several devices. To get a spark out of an ignition coil, the primary coil circuit must be turned on and off. This primary circuit current is controlled by a power transistor inside the ignition module or an igniter that is in turn controlled by one of these devices. We can have a pickup coil. It's a pulse generator, and most manufacturers use the rotation of a distributor shaft to time those voltage pulses. The magnetic pulse generator is installed on the distributor housing. That pulse generator consists of a trigger wheel, a reluctor, and a pickup coil. The pickup coil signal triggers the transistor inside the module and is used by the computer for piston position information and engine speed RPM. You're going to see a video on this, like an animation that I will include at the end of these things. So here's your typical pulse generator. When we have a magnetic pickup coil, it gives us AC voltage just as our coils do. We build a magnetic field, the magnetic field collapses, we get AC voltage coming out. That AC voltage is generally at idle, cranking around 0.6 volts AC. And as we spin it, it can be as high as 2 volts, 3 volts, 4 volts. I can get 9 volts with an electric drill with a distributor. So you can see the distributor rotates. This is the metal reluctor. You can see it gets attracted. Right? We have a permanent magnet here. As this rotates and creates a magnetic field, we start building as it pulls away. So as it pulls away and starts to collapse, we get our spike. The magnetic field's broken, and now it's AC, right? So now it pulls in the other direction as it comes back to the next one. And then and back and forth and back and forth. You see these windings that are around this? This is used to create a larger magnetic field. Over here, you can see your ignition module. This is your rotor in the middle, and this is your pickup coil that wraps all the way around. These points here would be this